Hello everyone, let's move on to the next example. In this example, we are going to use Bus.db database in order to generate plots for answering specific questions about the data. Now would be a good time to download Bus.db if you haven't already done that. I'm going to define Bus.db into a variable called path. And the first thing that I'm going to do is I'm going to assert that os.path.exists of this particular path. Why am I doing this? Recall that whenever you call a connect function with the name of the database where you have a typo, the connect function automatically creates a brand new database for you instead of letting you know that there is an issue with the name of the file. So you always need to assert that the database file exists before you go ahead and establish a connection. Recall that you need to use SQLite3.connect function, and it takes one argument, which is the name of the database itself, and it returns a connection object. Even though the connect function is very similar to open function, which you use in order to open a file for reading the content of a file or writing contents into a file, when it comes to open function, you explicitly mention write mode by using a W argument. Whereas when it comes to connect function, even if your database file name has a typo, connect automatically creates the brand new database for you. The next function that you need to recall is the pandas.readSQL function, which takes two arguments. The first one is the SQL query and the second one is the connection object. Couple of queries which you're always going to need are the select star from SQLite master query and select star from table name query. Let's first go ahead and run the first query, which is select star from SQLite master. That particular query enables us to get a list of all the tables associated with that particular database. Bus.db contains two different tables, which are boarding and routes. I'm interested in the boarding tables data, so I'm going to say select star from boarding. Let's look at what sort of columns we have here. So we have a couple of index columns, then we have a stop ID, then we have a route number. What exactly this stop ID and route number column are giving us is that it's saying that in stop 6543, route 71 had a daily boarding of about 7 people. That's what that particular information represents. And you're going to have a combination of the stop ID with various routes which cover that particular stop. Let's go through this question over here about the database tables data. It's asking what are the top routes and how many people ride them daily. Think about what clauses would you require for your SQL query in order to be able to answer this question. So you're trying to answer a specific question about routes. So clearly you need some form of a group by clause. And then the question is asking how many people. So that's going to be a sum of all the daily boarding column, correct? So let's go ahead and start writing this particular SQL query. So I'm going to say pd.read_SQL. I'm going to make my SQL span across multiple lines so that it's easy for me to write. So I'll have to do select something from boarding and then group by something, correct? What do I want to group by? I want to group by route. And what do I want to select? Whenever you apply a group by clause, you should either select just the group by column name or an aggregation function. So I'm going to do both in this case. I'm going to aggregate daily boardings column by saying sum of daily boardings. And let me rename that column as daily to make it easier for us to access. I'm going to capture the return value of this function into a data frame df, and I'm going to go ahead and display df. Looks like I missed out the connection object over here. Let me fix that. Right, there you go. You have each route and the associated sum of all the daily boardings for that particular route. Let's see how we can take this data and convert it into a series. Recall that you can extract a single column's value into a series easily by saying data frame of that column, correct? So I'm going to say s equal to df of daily, and that's going to extract just the daily column values into a series over here. Let me go ahead and create a bar plot using series like we have been using in the previous example. So I'm going to go ahead and do that. There is too much data in this bar plot, right? We are barely able to read any of the x-axis tick labels because all of those overlap with each other. Let's filter down this data to just the top 5 routes. How can you do that using the SQL query? I'm going to go ahead and copy paste the SQL query so that I can keep editing it. You can apply the limit clause in order to limit the number of rows that show up as output. So limit clause is also an example of a row filtering. You need top 5 routes. So clearly you need to order the routes by something because you don't have any kind of ordering in the above plot, correct? So I'll have to do the order by after the group by clause because you always want to do the ordering within each group. So I'm going to say order by the daily column, and I want the descending order, correct? The default is ascending. I want the top 5 routes, which means that I need the top 5 routes which have the highest daily boarding. Looks like these are the top 5 routes, 82, 6, 10, and 3 over here. Let me go ahead and produce the pie chart, sorry, not pie chart, what am I thinking? The bar chart again. As somehow the plots are taking way longer right now to produce. Give me just a second. I'm going to check what's wrong here. Okay, I forgot to update my series variable, so I need to go ahead and fix that. And now hopefully it'll be faster. Right. What exactly is 0, 1, 2, 3, and 4? Well, clearly that's coming from the row index in my data frame over here, right? Let's go ahead and fix that. We need the route numbers here instead of just having the row index values. I can do that by saying df dot set underscore index. What do I want to set the index by? I want to set the route column as my index, correct? So recall that this returns a new data frame. So I'll have to capture that back into df if I want to update the original data frame. And now I'll have to say s equal to df of daily to retrieve the daily column as a series. And then I'll have to say s dot plot dot bar. Right, so much better. The routes are labeled correctly. Not an unexpected thing that you would see here. Route 80 is the most commonly used route. Um, Sadly, I think it would probably be the less commonly used route nowadays because students are not going to be attending in-person lectures after Thanksgiving. Right. Wouldn't it be nicer if we had one more bar which represents all other routes? How can we do that? First of all, we need to go back to the previous version of the SQL query, which doesn't have the limit, correct? So I'm going to go and get rid of the limit clause over here. And let's one more time capture the series by saying s equal to df of daily, and I also need to set the index for my data frame as the route column. Hopefully route is the correct column name. Yeah. And then I can say s.plot.bar one more time. So this should take us back to plotting all of the route bars. The only difference is now we have the order by clause. So they're going to be ordered by the sum of daily boardings. Let's think about how we can take part of the data out in a data frame. You can use slicing always, correct? So when your data frame is the output of the query, which has like an order by clause, your first 5 rows are going to represent the top 5 busiest routes, and the remaining rows are going to represent the other routes, correct? So we are sort of interested in slicing up the data frame into 2 different parts. The first part is going to be the first 5 rows, and the second part is going to be all the other rows, correct? So I'm going to do that by using ILOC in order to do the slicing. So I'm going to say df, actually let me type from scratch over here. I'm going to say df of daily dot iloc, and I want to get just the first 5 rows. Recall that you can skip mentioning start and you can simply say :5. That's going to get the first 5 rows for you. What do we want to do with this? We just want to capture this into a series because we still want to produce a plot which contains 5 bars and then 1 additional bar, correct? So how can we capture the rest of the data frame rows? We can do the opposite, right? So we can say 5 : to get all of the remaining rows until the last row, so we don't have to mention the end. What do we want to do with all of this information? We just want to sum up all of those values into a single value, correct? So I can capture this return value into a variable called other sum, and I can simply add this back into the original series variable s by saying s of other equal to other comma sum. You can just use this similar syntax which you'll be using for a dictionary. You can say s of index equal to whatever the value is. Let me go ahead and display s over here. It looks like the other category has 29,000 something plus boardings on a daily basis. Let's go ahead and plot this data one more time. So I can say s.plot.bar, and that's going to get us all of this information over here. Let's use the get_ax function in order to fix the plot aesthetic aspects. So I'm going to say get_ax, and I'm going to give the same width as before because the width is hard-coded inside the get_ax function. I'll just leave the height as such with the default value, and let's see what happens. I'm going to capture the return value into a variable called ax, and when I call the plot function, I'll have to say ax equal to ax, and let's say that we want the color of the plot to be black, and we also have to set y label, correct? We'll have to say that as rides per day, maybe rides per day, and let's also get rid of all of these unnecessary zeros. Instead of using s, let's use s divided by 1000 so that our plot is more readable, and in my label I can say thousands in order to identify this particular information. Right, looks like that's the plot that we are getting after fixing all of the aesthetic aspects. I'm going to briefly introduce you to the concept of scatter plot. For scatter plot, we are going to be using data frame, And I'm going to take the data from trees.txt file, and I'm going to simply paste it into my notebook cell. So this contains a list of dictionaries with certain key value pairs. The way that you can call the scatter plot function is by saying df.plot.scatter. You're going to have two arguments. The x parameter is going to be the column name for the x-axis, and the y parameter is going to be the column name for the y-axis. Let me go ahead and show you how to do that. I'm first of all going to convert this particular list of dictionaries into data frame by simply saying data frame of trees. Recall that you can just pass any nested data structure as an argument to the data frame function and get the corresponding data frame. So if I go ahead and display the data frame, you'll find that all of the key value pairs have been converted into column and corresponding row values. So I'm going to say df.plot.scatter, and let's say that I want to have age as my x-axis column and height as my y-axis column. That's an example of a scatter plot. I'll wrap up today's lecture here. I wish everyone a happy Thanksgiving. If you're planning to travel, do so safely and take care of yourself and your family.